Hello guys, in this video I'm going to speak about the Bradford assay, everything about Bradford assay, the principle behind Bradford assay and the calibration curve used to measure the concentration of proteins in a solution. So let's see what is Bradford assay. So Bradford assay is a colorimetric assay. It depends on the color of the solution. It uses a spectrophotometer. It's a quantitative assay to measure the protein concentration in a solution. Now, how does Bradford assay work? Okay? The principle of Bradford assay. Bradford assay depends mainly on this molecule, which is called Coomassie Brilliant Blue. So Coomassie Brilliant Blue is a very special molecule and it has a character which is used for the Bradford assay, is that Coomassie Brilliant Blue can exist in two states, okay? The first is the unstable state, which is the cationic one, and the second is the stable anionic state. The very special about Coomassie Brilliant Blue is that the two states don't have the same color, but the unstable state is reddish to brownish, like the color you're seeing here. And the stable state is bluish, like the color you're seeing here. So this is the character we use for the Bradford assay. Now, how does it work? You have a protein, okay? You have a solution of proteins and you want to know the concentration of your proteins in the solution. It doesn't matter if you have one protein or 100 of proteins in your solution. The Bradford assay will give you the whole concentration of your proteins in the solution. So you have the protein solution. You take a sample of this protein solution, you mix it with the Coomassie Brilliant Blue in its unstable state. Okay, you mix them together. Now, the medium is acidic, in an acidic medium. Now, you should know that the proteins mainly are positively charged in an acidic medium. Why? Because of the isoelectric point. If you want to know more about isoelectric point, actually, I have a previous video. The link is in the description of this video. You go to the other video, you can know more about isoelectric point. But in general, I'm telling you, the proteins are mainly, it depends, but they are mainly positively charged in an acidic medium. Okay, so we mix the protein and the Coomassie Brilliant Blue. Now, the Coomassie Brilliant Blue has a lone electron pair. Okay, it has a lone electron pair. And it can give this lone electron pair to the protein. And where exactly? To the ionizable groups. So the protein is a chain of amino acids, and each amino acid has a side chain. So the protein may have many ionizable groups in its amino acids. So the Coomassie Brilliant Blue can give the protein this lone pair. And in this case, when the Coomassie Brilliant Blue give the protein a lone pair, the protein becomes unstable. Okay, because of the lone pair, it becomes unstable. And then we have in the solution an unstable Coomassie Brilliant Blue and an unstable protein. Now, the Coomassie Brilliant Blue is mainly negatively charged, the unstable protein is mainly positively charged. Okay, and then these two unstable molecules need to bind to each other in order to be stable. So they bind to each other first of all by ionic forces. Okay, because this is negative, this is positive, so they bind together by an ionic force, and then the attachment will be further worsened by hydrophobic van der Waals forces. Okay, why? Because the Coomassie Brilliant Blue has a non-polar region, and the protein, the unstable protein, has hydrophobic pockets on its tertiary structure, so they can also bind to each other by van der Waals forces. Now this binding, let's say, between the protein and the Coomassie Brilliant Blue makes them to be stable. Okay, and when the Coomassie Brilliant Blue is stable, it's not reddish anymore, but it turns to be bluish. Okay, so the unstable Coomassie Brilliant Blue becomes stable, and then the color becomes bluish. So this is the main principle of the Bradford assay. This blue color depends on the amount of proteins inside the solution. So when we have a little bit of proteins, the bluish color will be light blue, and when we have more proteins in the solution, the blue color will be darker. So the darkest the blue color is, the more protein we have in the solution. This is the main principle of Bradford assay. Okay. Now these are the two Bradford solutions. So this is the unstable Coomassie Brilliant Blue. Okay, it's reddish or brownish, we can say. This is the stable one, it's bluish, and the blue color depends. The blue color varies from light blue to dark blue depending on the amount of proteins inside the solution, okay? Now this one, the reddish, the unstable Coomassie Brilliant Blue absorbs light at 465 nanometers, okay? But this one absorbs light at 595 nanometers. And then we can say that the main principle of Bradford assay is this. So the more the solution absorbs light at 595, so the more this solution can absorb light at 595, it means that the more bluish color there is in the solution, and which means we have more protein. The higher is the protein solution in the higher is the protein concentration in the solution. Okay, this is the main principle. Okay, it depends on the blue color, and so it depends on the absorption on 595. Okay, now how can we measure the concentration of the protein in the solution? To measure the concentration of the protein in the solution, we need a calibration curve. And how to make the calibration curve? Okay, we take a protein, another protein of a known concentration. Mainly we use BSA. So BSA is a protein used to make the calibration curve. Calibration curve, some people call it the standard curve. Okay, so to make the standard curve or the calibration curve, we use BSA, bovine serum albumin. We take a BSA solution of a known concentration. Let's say we have like 2 nanogram per microliter, okay, and we produce several concentrations or several dilutions of this in Coomassie Brilliant Blue. What we get is this. So let's say this is Coomassie Brilliant. This is only Coomassie Brilliant Blue without any proteins. Here, let's say we add 1 microliter of this solution. We add 2 microliter, 3 microliter, 4 microliter, and then we will have like serial dilutions of the BSA protein, like 2 nanogram per milliliter, 4, 6, 8. We can produce more. We can make 10, 12. Okay, we can make it as much as we want. We can make 1 nanogram per milliliter, 3 nanogram per milliliter. We are free to make as much dilutions as we want. So if you look at the color here, so when the Coomassie Brilliant Blue is alone, it's like reddish. 2 nanogram is not so obvious, the bluish color is not so obvious. Then 4 nanogram, it becomes more and more bluish. Okay, now we take these cuvette and we measure the absorption of these solutions in a spectrophotometer on 595, because we want to see how much bluish color we have in the solutions. Okay, we use the Coomassie Brilliant Blue as a blank in the spectrophotometer, and then we measure the absorption of the other solutions. Then we will get something like this, a curve. So in the y-axis, we have the absorption of the solutions, okay? And in the x-axis, we have the concentration. as I told you, we can have as much concentrations as we want. Okay, here I assumed we have 1 nanogram per milliliter, 2, 3, 4. We are free. Now, normally the absorption should not be more than 0.1. If you get an absorption more than 0.1, then you should dilute your protein sample more. Okay, because more when the absorption is higher than 0.1, it will not be very precise. So better to have absorption less than 0.1. Okay, then you will get a curve. It looks somehow like this. Okay, the higher concentration you have, the higher absorption you will get. So we don't need this, we need the linear curve. Okay, so we get the linear curve, and we get the equation of the curve. Now we have the equation. The y is the absorption, x is the concentration. So if I have a protein sample, okay, let's say I have a protein sample of an unknown concentration. I take, let's say, 1 microliter of this solution. I mix it with Coomassie Brilliant Blue. I measure the absorption, and then I say the absorption is y, and then all I have to do is to calculate the x, and then I will get the concentration of my proteins. Okay, this is everything I wanted to tell you about a Bradford assay. I hope you enjoyed the video. If you really enjoyed it, please like the video and share it with your friends. And yeah, thank you for watching. See you in the next video. Bye bye.